Hey guys, this is Shari Luthra from Mrs. BJ Physics Honors Class, Period 6, and today I'm going to show you how to do problem 6.16. Alright, so the problem states that a 120 volt battery of negligible internal resistance is connected to the following circuit. I'll show you the circuit on the next page. We are asked to find the following: the resistance of the light bulb, the equivalent resistance of the total circuit, and the current of the total circuit, as well as the voltage across two different resistors. We are given that resistor 1 has a resistance of 17 ohms, resistor 2 has a resistance of 12 ohms, resistor 3 has a resistance of 1 ohm, resistance 4 has a resistance of 14 ohms, resistor 5 has a resistance of 63 ohms, and we're also given the fact that the light bulb has a power rating of 40 watts. Here's the circuit diagram. Here's our light bulb, here's our resistors 1, 2, 3, 4, and 5. And here's the first voltmeter we have to find the voltage for, and the second voltmeter we have to find the voltage for. Alright, so the first thing we're asked to do is find the resistance of the light bulb. To do so, we use P equals V squared over R. We then set the power of 40 watts equal to the voltage that will reach the light bulb of 120 volts squared over R. Then manipulating the equation, we can get that R is equal to 120 volts squared over 40, and finally that our resistance is 360 ohms. So what the next part asks us to do is to find the equivalent resistance of the full circuit. So basically we will first find the equivalent resistance of each of the branches of the parallel circuit. So to find R12, we basically add resistance 1 and resistance 2 to get 29 ohms. And to find R345, we add the resistances of 3, 4, and 5 because they're all in series, and we get a resistance of 78 ohms. So basically what we do next is we find the equivalent resistance across the three parallel branches. Since these are all parallel, we're going to use the fact that 1 over R total equals 1 over R12 plus 1 over R345 plus 1 over R the light bulb. So that's 1 over 29 plus 1 over 78 plus 1 over 360 ohms. We get 1 over R is equal to 1 over 0.05008, and then finally that the equivalent resistance of the full circuit is 19.96 ohms. In part C, we're asked to find the current across the entire circuit. So we know that I total is equal to V over Req. We know that the voltage is 120 volts and that the equivalent resistance is 19.96 ohms. Therefore, that I total is equal to 6.01 amperes. In part D, we're asked to find the voltage of resistor 1. So to do so, first we find the current at R1. So to do that, we use I equals V over R. We know that the voltage is 120, and since R1 is in series with R2, the current is going to be the same across the two resistors, so we have to add the resistance and then solve for the current. So we get I is equal to 120 over 29 ohms. By plugging that into our calculator, we get that the total current at R1 is 4.13 amperes. Then to find the voltage, we use the calculated current and the resistance of R1. We know V equals IR, so therefore the voltage is going to equal 4.13 times 17 ohms, which is the resistance of R1. Finally, we get the voltage is equal to 70.2 volts. In part E, we're once again asked to find the voltage across the resistor. For this time, we're asked to find the voltage across the resistor R5. So to do so, just like in part D, we first find I at R5. Using I equals V over R, we plug in 120 volts for our voltage and R345 for our resistance, because 3, 4, and 5 are in series and therefore have the exact same flow of current. So we get I equals 120 over 78 ohms, and finally the I is equal to 1.53 amperes. Then finally, we'll use V equals IR to solve for the voltage at R5. We get V equals 1.53 times 63 ohms, which is the resistance of R5, and then finally that voltage is equal to 96.39 volts. This checks out because the voltage across the three different parts of the circuit all but add up to the original 120 volts. Thanks for watching. I hope this helped you. Have a good day.